Okay, so this is part 2 of the measurement lecture on significant figures, or sig figs, as we call them. So going to the PowerPoint, and remember it is available on Canvas. All right, so significant figures are very important, and most importantly, the rules for the math of sig figs. When I talked about measurements, you have a certain number of digits based on what you're using to measure and the uncertainty associated with it. So in this case, the uncertainty, remember, determines the number of decimal places your measurement is given in. And there are rules to determining what is a sig fig, which is the shortcut way of saying it, what's significant and what's not. And most importantly, how we use these rules for calculations. When you're adding or multiplying or dividing or subtracting multiple measurements, how do you determine how many digits should be in your final answer? Those are your rules. So know these rules. Put this reference slide somewhere. These are your core rules. Any non-zero number is significant. So that tells you right now, this has to do more with the zeros. How do you know if a zero in a number is a placeholder or meaningful? And you follow these rules. So a non-zero number is always significant. Zeros in between non-zero numbers, regular numbers, are significant. So they obviously have to be there. If a zero is between your first set of real numbers and decimal, it's not significant. It's a placeholder. Okay? I need these zeros to tell me that my actual measurement starts at the fourth decimal place back. For this reason, this is one of the biggest reasons, that we use scientific notation, which I'll get into in a little bit. So these zeros are placeholders. I can rewrite this. Okay. I'm going to switch to my whiteboard. And I wish it didn't take so long. So that number was 0.00012. We'll call it grams. I can rewrite this and get rid of those zeros and not lose my information. Numbers are information. So it's going to be 1, 2, 3. I'll do it 4 places back. So it's 1.2 times negative 4 grams. This is scientific notation. This is a way to write our numbers, our measurements, our data, using only the significant digits. So this tells me I have to go 1, 2, 3, 4 places to write it out as a regular number. So the question you ask yourself is, if a zero is significant or not, can I rewrite my number in scientific notation and not lose any of the information? If you can, then those zeros are not significant. They're placeholders. So a zero between a decimal place and the first digit is a placeholder only, and they're not significant. Okay? So back to the slide. Okay, so that's here. A zero at the end of the number, if it is after a decimal place and there's nothing else after it, it is significant. The only reason for this zero to be here is because it's important. So that says that whatever you measured this on had the precision to go all the way to the third decimal place. So zeros after the decimal place at the end are significant. A 0 in front of the decimal point, notice there's not a decimal point here. So just a 0 at the end of a whole number may or may not be significant. You have to know the context. Sometimes you'll see a decimal point and nothing else. That generally, I was never taught this, but I have had students who have been taught this, that if you see a decimal place, that's a way of saying this is significant. So I don't use that myself. But if you see it, that's what it's implying, and that's what Alex likes. But if you're given this number just by itself, you can't tell me if it has 3, 4, or 5 significant figures. You have to have the context of it. Now, if this were written in scientific notation, you could say 1.0300 times 10 to the 1, 2, 3, 4. And that tells you, yes, those are significant. Or you would say 1.03 times 10 to the 4. And that tells you that they're not significant. So scientific notation helps tell us what zeros are significant. So learn these rules. You're going to use them a lot. So here's some examples. How many sig figs does each of these have? Well, 210. You have no context here. So you actually don't know if this is 2 sig figs or 3. You don't know if this is a 0 there because you can't not have it. So it's either 2 or 3. This one, this 0 is simply a placeholder. I can rewrite this in scientific notation and get rid of the 0 and not lose any of my data, my information. So this has 2 sig figs. This 0, on the other hand, is back here at the end on the other side of the decimal place. Therefore, it is significant. Anything to the right of the decimal place is significant if it's by itself. So this is 3 sig figs. This one you don't know. It's no context. You don't have the numbers that got you here. So it's either 4 or 5. This one is important because it's in between digits. So this is the one you don't know about. However, when it's written like this and that last 0 is on the right-hand side of the decimal place, it is significant. There's no other reason for it to be there. So this is 5 sig figs. When we do math with these numbers, there are rules to follow. When you multiply or divide, you're going to count the number of digits. Your final answer will be given in the lowest number of sig figs. However, you do not round your numbers up or down until you are completely done with your math. Because when you round, you're adding or taking away information. So, for example, what if you had to do a number of other calculations on this? You would not give the final answer or give your answers with 2 sig figs until you were completely finished. So you count the number of sig figs for multiplying or dividing, and your final answer will be given in 2 sig figs. So what does that mean? That means that only these 2 decimal places, these 2 places are significant, which means you have to round up. So it's going to be 440. And no decimal place. Because if you have a decimal in here, you've just changed the number of sig figs. So now it's 440, or you see if we write it with scientific notation, it's much clearer, 4.4 times 10 to the 2. So that's easy to see that it's 2 sig figs. That's not quite so easy. So after you're done with all your calculations, that's when you round off your answer to the number of sig figs. And I don't have So I don't have my calculator out to do these, but how many sig figs are these answers going to be? So this has 5 and this has 4. There are no zeros. These are all significant. So your answer is going to be 4 sig figs. So it will be this one. These zeros are significant because they're in between digits. So this is 4 sig figs and this is 2. Therefore, your answer is in 2 sig figs. Now, I'm going to assume that if I multiply that, this is what I'll get. So 2 sig figs is going to be these 2 places. And so that means that 120 is your answer, because you have to round it up, your 7, to make it 120 for 2 sig figs. If you are adding or subtracting, you're not counting, you are lining up your decimal place. Okay, so I'm going to go back to the whiteboard. And I don't have that example in front of me, darn it. So let's just make up some numbers. So 3.17, 4.1, and 25. All right. You line them up. There's an invisible decimal point here. You line them up so that they are all, the decimal points are in a row, are in a line. When you give your answer, your final answer decimal place can only be at the smallest decimal place. In other words, this one. So this place, this number placement is your final answer would be. So first you do the math, we're adding this. And 7, 12, 3, that's a 2, okay? 32.27 is what I get, but that's not my answer. My answer has to be rounded to this decimal place, because when I line them up, this is the closest to the decimal point. There's nothing here and there's nothing here, so I can't put anything in those places. So this is less than 5, so my answer is going to be 32 to that decimal place. What if those were my numbers? Again, line them up. Addition, subtraction, you are lining up by decimal place. You can actually physically do this, or you can just mentally do it to let you know your answer has to be in what decimal place. There's nothing here or here, so it's not going to be in either of these. So your final answer has to be to this decimal place. So if we do the math, this is going to be a 5. That's going to be a 0, 1, 2, 3, 4, 5, 9, 10, 11, 12, 3. So 32.505, but because this is my closest to the decimal, that's the place that your answer has to be given in. So the answer is 32.5. You do not count the places, you look at location. And you should have plenty of Alex homework problems like this to get you used to it. All right, back to the PowerPoint. Okay. And remember, these slides are available to you. So in this example, The 49 has nothing over here. So the 9 place, the one spot, your answer has to be, can't be any more digits than that. So it'll be 206. Because there's nothing over here. So we can't have the 3 or the 7. Rounding is simply using, if the neighboring number is 5 or greater, you round up. If the neighboring number is smaller than 5, you don't round up. You keep it the same. So just go back and refer to this slide. You probably all should remember that from just your high school math. All right. What if you are combining different types of math? What if you're doing addition and multiplication? What do? You have to follow the rules as you go along. You have to keep track. So I wish I had a huge whiteboard for this. Very important, do not round until you are completely done with your calculations, or your answer will be wrong. Whenever you round, you're either gaining information by rounding up, or you're losing it, and that's going to affect your math. So do not round until you are completely done. Then you go back and you find your number of sig figs. So how many sig figs does this have? This has 2. This is multiplying. So this and the answer from this are going to have how many? Well, first of all, you have to do the addition, what's in the parentheses first. So we're going to go back to the whiteboard. Okay, this time I wrote it down. Okay, so there's the problem. Where do you start? You start with what's inside the parentheses, always. So 5.67 minus 2.3. Line them up by the decimal place, right? So that's the answer you get. So I'll write that over here. But how many sig figs does this one have? Well, again, since it's addition and subtraction, you're not counting, you're going by place. And it's got to be this place because of this. There's nothing there. So what I do is I underline my sig fig notation or location for the addition and subtraction. Now, this will be multiplied times this. You do not round this yet. You multiply 3.37. But you keep in mind that this only has 2 sig figs, right? Because we're at that decimal place, so it's this and this. So now I'm multiplying this times this. You're going to get an answer. This is 4 sig figs. And you're multiplying it times something with 2 sig figs. When you're multiplying and dividing, you count. So your answer has to be the smaller number of sig figs. So once you get your answer with your calculator, you round up or down to 2 sig figs. So write your number for the parentheses, underline, if it's addition or subtraction, where the sig fig is. That helps you keep track as you go along, because you will have mixed math sometimes, and it can be tricky. Okay, back to the slide. This used to be faster until they broke Zoom. Come on. There we go. So there's my 3.37 times this. When you do that multiplication, you get this long number. However, because this really only has 2 sig figs, my final answer will be rounded up to 12. This, with practice, gets easier. So what would this be? Well, this answer is going to be to this decimal place, the second decimal place, 11 minus 3. So it's actually going to have 2 sig figs, because this is going to be, what, 7 something, I think. So it'll be this place and just the other side of the decimal place. This will have 2, and you're multiplying it times something with 4 sig figs. So your answer will have 2 sig figs, and that's this one, D. Now we know this is 2 sig figs, this 110, because we see in context that it came from this math problem. So therefore we can say, oh, this particular 110 is 2 sig figs because we know where it came from. We have it in context. If you just saw that number randomly with no context, you wouldn't know that if it's 2 or 3. All right. So scientific notation, as I said, is a way of writing either really big numbers or really small numbers in a concise way, but also showing what are the sig figs. Very important for that. It's the power of 10. So really, if you move your decimal place, so here's my decimal place here, my invisible decimal place. If I'm going to move it to the left, then the new scientific notation is written with it saying it times 10 to the 2, because what we're saying is that to write this out in a long form, you have to move this decimal place 2 places to the right. You can probably find some good videos. I think there's some in the Canvas help. You can probably find some on YouTube. If this is confusing, if you haven't done it in a while. But Avogadro's number, for example, has 23, is 6.02 times 10 to the 23. We're going to use that number later. If we wrote that out, it would look like this. Okay, you don't want to do that. So this is the other reason we use scientific notation, is for writing out really long numbers in a concise manner or really tiny numbers. And also, you know, this only has 2 sig figs. You don't have to worry about those zeros because we don't include non-significant zeros in scientific notation. This is just a little cheat sheet about, I get confused which direction I'm supposed to go with sig figs. That is one of my areas of error. So this is a little guide that you can refer to if you're not sure what the sign of your exponent should be. There is a button on your calculator, and I think there's also one called F/E. I think there's one is on some calculators called F/E, and it will change the display from regular numbers to scientific notation. So you don't want to sit there and count zeros when you're doing your math. Make it display for you in scientific notation. When you are entering that 10 to the 2, 10 to the 3, you use the EE or the EXP button. So if anybody's confused with this, they don't know how to do it, bring it up at the next lecture or pop over on office hours and we'll go through it real fast. And again, you can probably find videos. So it's important to use the shortcut keys on your calculator to get comfortable with it. It's going to go a lot faster. We'll be using calculators a lot. All right. going to skip these. You can go through these. These just that's some practice. Real quickly for units, we use the metric system in chemistry. In your first couple of weeks and probably on the final, you will get some conversions, and that's the next lecture. Converting between standard units, feet, inches, ounces, to metric, just so you can get the practice from that. But really, we don't do that in the lab. We stick with metric. But it's important to know how to do the conversions. All right. So you do need to know, metric is based on 10, power of 10, which is what's really great. Everything is 10 times or 1 to the 10th by the power of 10. Come on. You need to know these guys, the deci, the centi, the milli, and you should know the micro as well. But you absolutely have to know the first three. These are on the right-hand side of the decimal place, and know these. Well, you're not really going to get a hecto or a deca, but know these. There are some good mnemonics, memory jogs to help you remember the order of these. I'm trying to remember some off the top of my head. There's something about King Henry, but look that up for mnemonics for memory jogs for the metric system to help you remember the order that these go in. So you do need to know that milli is 1,000ths, 0.001. You need to know that mega is 10 to the 6. So okay. All right, I'm going to stop there. Unit conversions will be a third lecture to work through some of those.